Here's an example of a geometric sequence. We want to find the number of terms in the sequence. So term 1's value is 2. Term 2's value is 4. T sub n is 128. And we want to find out how many terms are in this sequence. So let's start off by first finding the common ratio. So to find the common ratio, you start with a term and divide it by its previous term. So term 2 is 4. Term 1 is 2. So 4 divided by 2 is 2. So the common ratio going from one term to the next is multiplying by 2. So we could move forward and multiply by 2 and get 8 and continue finding the terms. Well, this could take us quite a while. So instead we're going to use the explicit formula that is below. And we're going to substitute in the three pieces. T sub 1 is 2. T sub n is our last term in our sequence. And then our common ratio we just found to be 2. And what we're going to do is solve for n. So let's substitute in. 128 is the last term. 2 is the first term. Common ratio of 2, and then raised to the n minus 1. And we want to solve this for n. So our first step to solve this for n in this exponential is to divide both sides by 2. What happens is these 2's cancel out, and then we have 128 divided by 2 on the left is 64. And then now on the right we have 2 raised to the n minus 1. And we want to find out what n can be. So we're going to take the common log of both sides. So we're going to take log of 64 equals log of 2 raised to the n minus 1. And what this allows us to do is to bring down this exponent down in front. So now it's n minus 1, and then I have the log on the right, and then the log on the left. Now we're going to solve for n minus 1. So we want to undo the log of 2 on the right. So we divide both sides by the log of 2. Log of 2. And what cancels is the log of 2's on the right. We're left with n minus 1 on the right. And on the left, we have the log of 64 divided by the log of 2. Now we need to use our calculator. So remember, we're pushing the common log button. Log of 64. Finish the parentheses. Divided by log of 2. Finish the parentheses. And what you get is 6. And then we still have on the right n minus 1. Our last step to solving this equation for n is to add 1 to both sides. So n equals 7. What that means for this problem is there are 7 terms in this sequence.